It's going to be a video that basically breaks down where integration by parts comes from. So first thing I'm going to do here is that I have this u and v equation. And it is important to note that these two equations here are both with respect to x. So they're just defined with respect to x. And the first thing I have right here is this first line is the derivative of u times v is basically product rule. So that first line I have is basically just product rule. What I'm going to do first is the antiderivative of both sides of these with respect to x. All right, so it got kind of sloppy here, so I'm going to clean this up a bit. This dx times this dx is going to cancel, and then we have the integral of this duv is just going to be uv. So I basically just went backwards. I was doing the derivative of uv, now I'm doing the antiderivative. Okay, over here, this u prime, I'm going to rewrite that to be du over dx times v, and then I'm going to distribute this dx right here to it. So times dx. And then I'm going to add, this integral is going to distribute to both of these terms here. So I'm going to do the integral of dv over dx. So basically I wrote this v prime here with dv over dt. So it's the same, it means the same thing, it's just different notation. Times u times dx. Okay, a number of things are going to simplify here. And then you end up with uv is equal to v du plus u dv. And the common format for the formula for integration by parts basically solves for this thing right here. So basically it's written like this: u dv is equal to uv minus the integral of v du. Okay, now what does all this mean? How do we actually use this formula? I wanted to show you where this formula comes from first. Actually, how to use this to solve problems. The best way of explaining that is with an example. So the next video is going to be an example video of me using this integration by parts formula in blue here. If you have any questions about any of this video, let me know.